Okay, I'm Tony Virelli, and tonight I'm going to talk about key duplication. In the email, I think we said I was going to cover 3 methods. I'm only going to cover 2. I'll just briefly describe the 3rd method, but I'm not going to actually do them here. So who am I? Tony Virelli. I do lock sport, and I like doing lock picking and other aspects of physical entry. So the 2 methods we're going to cover tonight are going to be 3D printing a key and then molding and casting a key. The other thing I'll just touch on at the end, it's not going to be part of my slide presentation though, is impressioning. So number 1, 3D printing, and it's way easier than you might think it is. So here's what you're going to need. A 3D printer, obviously, and then you'll need the filament for the 3D printer. I've tested it with multiple different kinds of filaments, but both PLA and ABS will work the same. You will need access to the key that you want to duplicate. However, that could actually just be a photo of the key. Or you could just have a list of the depths of the key's cuts. And then you're going to need a website. You don't need it, but it makes it a lot easier. A website called keygen.co, which I'll get to here in a second. So 3D printer, obviously I use TechKnow 3D printers to do this. So I printed mine on the Ultimaker 2 Plus. The key I used was this one right here. It's for a lock I already own. This is a Kwikset KW1 keyway. And it goes to this lock. And then measuring tools. So the measuring tools you can use are either A, pair of calipers, or B, a standard key depth gauge. And the way this works is on the front of here, it's got like Westlock, Master, Weiser, Schlage, and Kwikset. And you just take your key, there's numbers across here, and as you run this across, it'll stop on the cut. And you know that's the 3 cut. You go all the way over, that's a 4 cut. You just go and you can just get your list of cuts doing it that way. That's not how I did it because I didn't originally have this when I first way back started doing this. I used the calipers. And then Deviant Ollam on his GitHub page has pictures of the most common keys showing the spacing for the cuts and then the depths that you need to make each cut. And I just used a pair of calipers to figure that out and found out the numbers for my cut depths. And then the website, keygen.co. This website is amazing. You can literally select your keyway, your warding, or you select your manufacturer first, your outline, which is, there's difference, so it might be a 5-pin or a 6-pin. The warding, because obviously Schlage has a crap ton of warding options. And then you put in your bidding code, and some of these get crazy. So on Schlage and Kwikset and Master, they're super easy. They're numbers. But some, like some of the metacodes that have offset cuts, you have to put letters in as well to tell whether it's like a left cut or a right cut and how you do that. So that's the wording. And like for a Schlage Primus, where it's a double row, you actually put a dash in. The first one specifies the main cuts. Everything after the dash specifies the second cuts. So here's a quick little video demonstrating how to use the website. I'm just doing it for this Kwikset. So I select Kwikset. There's only one type of out key for Kwikset, which is a KW1. And then for the bidding, I just threw a quick number in. It's actually the demo number they show you. Hit generate. And wait, and boom. It creates a 3D render of the key. And then I can download that STL file. And then Windows has a 3D viewer built into it, I guess. I didn't realize that when I clicked on it because I'm used to doing this on a Mac. So it opened up this 3D viewer. And apparently Windows software thinks it's going to cost like $14 to print this key. Yeah, $14.31 to print this key. That's not true at all. So anyways, I then later opened it in Cura, which is the slicer software for the Ultimaker. And that's how the key, the first time I printed it just the way you see it with supports. It took forever, and at a certain point, the head would make the whole key wobble back and forth, so it didn't work the best. So now when I print it, I actually rotate it so it's flat, and the only place you have to have supports is the bottom warding. So it's an easy strip you just peel out of the bottom of the key, and you do have to do some sanding to it to make it fit properly, and an X-Acto knife maybe to cut a few pieces off. But that's showing it with a brim. I do not do a brim. I just use the default settings to show this. I do it with a skirt around the outside. So here's a video of the first key I ever printed. I actually stopped it to test it. That's why the top of the key doesn't exist on that. Put it in, and that was an awesome thing. I couldn't believe it just worked. There was a lot of sanding. That's why you see a lot of that black crap. That's dust from the sandpaper. So demo time. So here's the original lock I did. This is the quickset deadbolt. This is, well, here. This is the original KW1 key, which works as it should, obviously. And then this is a 3D printed key. Works just as well. Just today, I never printed one before, but one of the things that the keygen.co allows you to do is master locks. So this is just a standard master lock number 3, the original key for it. And this one I printed and did absolutely no sanding, nothing to it. And it worked perfectly. And then for that again, I just used the key gauge to get that and the calipers to verify it, because this master lock on this one's a little iffy. On padlocks, the depths only go up to I believe 7, but this decoder says it goes up to 9, which is not correct. So I don't know, because American Lock is owned by Master, and they can go to those depths, and there's a whole conversion for that. And then just for fun to show, if you guys want to come look at it, I printed off a whole bunch of the other keys. So here's a Schlage key. This is a Best keyway. This is a Schlage Primus keyway, and these are both Medicos. And if you come up and, this is a classic Medico, and I can't remember the name for this one, the dual something or other, but if you look at this, when you come up and see it, you'll see that some of the teeth angle this, or are angled like this, and some of the other teeth are angled the other direction, for security purposes, obviously. So, sandpaper and a X-Acto knife, like I said, are the only things that you will need. Okay, so now the fun one that has a better demo, which is molding and casting a key. Feel like James Bond and get to play with fire. So where I got the idea, I saw a video from Deviant Ollam that he posted on his YouTube channel. I've always wanted to try this out. I've seen it in the past from other videos, but the whole step-by-step was not there. And every time you saw the clamshell they used to mold the key, it's from like a billet of aluminum. So someone is actually milling this out and CNCing it out. I didn't have access to that, so I thought it was out of the range until Deviant's video said that you could use 3D printed materials. So I went on Thingiverse and looked that up, and I'll get to that in a minute, but there was a clamshell made by somebody on Thingiverse specifically following what Deviant's looks like. So there's a link to Deviant's video, and this will all be on the description of the video as well. So what you're going to need. For this case, you will actually need access to the original physical key, not a picture of it. So you need a physical access to the key. You only need it for like 30 seconds though, because you can have a lot of the setup to go before you get in there. You're going to need a low melting point metal. Commonly used metal is called Woods metal. It's got like a, don't quote me on this, but I think it's 120 degree Fahrenheit melting point. But it contains lead and calcium, I don't know the other, it's another chemical that it's not good to inhale. Let's put it that way. It's very toxic. And since I was going to be doing it in this area, and I wasn't going to wear gloves, and I was possibly going to inhaling it myself, I didn't want to buy Woods metal. I did some research and talked to some people on the tool Slack channel, and one of the guys suggested using Fields metal. It's got a melting point, I believe, of between 140 and 160 degrees Fahrenheit. The real problem, the benefit, non-toxic. The downside is that for a 1/4 pound of it, it was $35, where I could have got a whole pound or more of Woods metal for that. But you'll see here in a minute, I didn't need that much for doing what I'm going to be doing, since this isn't something I do in a day-to-day kind of scenario. You're going to need a way to melt down the large chunk of metal that you initially get. I ran to Walmart. Deviant has a picture or a video or a picture on the tool channel that showed this little like bulbous, like size of a baseball melting cast iron pot. I found it on Amazon and it was like 25 bucks. I was walking through the camping section at Walmart and found a like 6-inch cast iron skillet for 5 bucks. So I bought that, way bigger than it needs to be. You'll see a video of that here in a second. So I put the initial block that I got off eBay of the Fields metal in there just to initially melt it down. And then you need to make the ingots for the metal. And again, Deviant showed these really cool little square cubes of metal. And I'm like, man, how did he get it in these perfect cubes? And someone, again, in the tool channel on Slack asked, what'd you do? He's like, oh, that's easy. And he showed these. These are silicone ice cube trays for tiny, tiny little ice cubes. And I think I paid $10 and you get 2 of them. So one you can actually use for ice cubes. So I bought that, and you just pour your melted metal out of the cast iron skillet into that to make all your little ingots. And out of a 1/4 pound, I got, I don't know, 18 of them, which each one of those ingots will make 1 key. And again, once you make the key, you can remelt that key down again once you're done with it and use the metal over again. You're also going to need sculpting clay, which this is Sculpty. This was $3 on Amazon for 4 pieces. 1 piece will make you a key. Deviant's video says you can't use it more than once because it does get oven baked and it hardens. But when I did it with with the Fields metal, mine was still pliable. So I think I can use the piece again. We're going to try to use it for a second time tonight. You're going to need talcum powder as a release agent. So I just bought a travel size bottle of baby powder. Works perfect. And then a clamshell to hold the clay during the casting, which is right here. So this is the 3D printed clamshell, which you put the clay in. And then the guy who made it actually made a base for it, which is nice, because in Deviant's video he uses some kind of a metal clamp to clamp down and just hold it. This actually has the base this fits in and holds it all upright for you while you're pouring. And then you're going to need a ladle to melt the single ingot down to pour in. This was on Amazon. This is the one Deviant used in his video. It was $10. It's just called a lead ladle. And last but not least, you will need a heat source. And a long time ago I bought this. It's a cigar torch. So like I said, you're going to need the key to duplicate it. The Fields metal, I got mine off eBay for $35. There's a link to the product, which again I'll put in the description. The guy has a 100% sale rate. It's kind of cool when you look at it. He obviously molds it in that Lego set because the bottom of the brick I got actually had the indent of Lego with the reverse Lego logo in it. So, cast iron skillet, $5 at Walmart. There's the ice cube trays off Amazon. There's the link to them, $10 for both of them. The sculpting clay, I got mine for $3. It depends on color. Like the black is like $6, I think. So I literally went through every color and found the cheapest one. Talcum powder, bought mine at Walmart. And then there's the 3D printer, printed file. ZBZZN is the guy who printed this. I really should look up his name. It's on there. I believe it's, I don't want to butcher it now, so I better look it up. I only know this because he recently said something on Twitter. Okay. Boris Kozorovitzky. Sorry for butchering your name. Boris. Anyways, he created this 3D file, and that bit.ly link will take you to the Thingiverse page for his file. The melting ladle again I got off Amazon for $10. And the cigar lighter, I bought this quite a while back, like 2016. I think when I went back to look at my Amazon order history, I paid $15 for it. You can get these at gas stations anywhere. You can go a heck of a lot cheaper. Okay, so this is a video of me melting my original brick of metal that I got from Amazon. And I put wax paper down below in case I spilt any metal over the side. I didn't know how this was going to go. The one thing I would say that I would do differently this time is I put the metal right in the middle because I didn't know how well this is going to melt. I didn't know how this is going to go. And then I used a wooden skewer to like stir it because I thought that was going to be something I had to do. If I did this over, I would have put the block of metal right next to the edge of the pan where I was going to pour out of, because you'll see here in a minute how much waste is actually stuck to the bottom of the pan that I cannot get out. I assume if I took a blowtorch to it, I could probably melt it all down holding it at an angle. But I rolled it around seeing if it was melted enough, and pretty much wherever you see metal now, there will be metal later. So I maybe lost 1 to 2 ingots of metal out of there. Maybe, probably just 1. So once I thought it was melted down enough, I poured it into the ice cube tray. And you'll see that like some fill up right away, and the rest of them, there's like chunks. So after it cooled completely, I took the chunks out, put them in the little ladle, put all the small chunks, melted them all down together, and slowly filled each cube one by one to get as many ingots out as I could. So demo time. Caution, don't try this at home, or just don't blame me if you get hurt. So I'm going to adjust the camera a little bit here so I can zoom in more on what we're doing here. Get everything set off here to the side. So to start with, you take your clamshell, lay that flat down, get your Sculpting Clay out, and pretty much they come in these solid rectangular blocks, same size as this. Just rip it in half and then kind of roll it out to generalize the size of this. And I started at the bottom and I pushed the clay down in just to fill the entire gap, trying to keep it in because you don't want it thick. You literally want it up to the line, and you need more at the top, and I'll show you why here in a second. Deviant uses in his video, he suggests the possibility of using a plug follower, which is round, almost like a rolling pin. And then another option is he takes, like at the end, he takes I think a half diamond and scrapes it flat. When I did mine, I didn't have to do any of that, and it worked fine. So I put the clay in like that. And then the important thing is I'm pressing down right here because I want to create an easy well to pour it into, and it creates a little kind of handle at the top. So do that on one side and then do it again on the other. And by the way, when I did this the first time, there was absolutely no warping or melting or any concern at all. The fact that I was using a 3D printed piece, and that makes logical sense because even if this field's metal's melting point was 160 degrees Fahrenheit, PLA's like out of the printer head nozzle is 210 degrees centigrade. And I don't know what that conversion is, but it's hot. It's things like 400 or 500 degrees Fahrenheit. So the melting temperature is still high enough that it doesn't get affected when you pour this in because the metal's low enough. Okay, so I think that should be good enough. If we have a failure, I have a key already cast to show, so we have a backup plan. So you have both sides of your mold like that with your clay inside of it. And next, baby powder time. So you just sprinkle a little baby powder, and this is just a release agent because if you don't do this, when you pull your mold apart, your clay will be stuck together. Okay, doesn't have to be pretty. So as long as it's not sticky on your finger. So the next thing you need is obviously your key. So to place your key, you don't want to jam it all the way down in, but you want to get a good portion of it towards the bottom. And obviously it has to follow the clamshell mold here. And like Deviant said in his video, the important part here is you don't want to shove the whole key all the way down into one side. You want to kind of look at the top of the warding, or excuse me, of the key itself, and go about halfway. So I didn't push all the way in. It's stuck in there enough. So now I will take the other side, line it up, and then press it down, hopefully. And every video I've ever seen this, they say step on it. They'll apply weight to it to make sure it fully goes. So this is 3D printed, so I'm not going to put all my weight on it, but I did do this at home, and I suggest it because it flattens the clay out and gets you a good closure on it. Okay, so that should be it. So now I should be able to take one end off. And hopefully I didn't wiggle it too much there. So I have a negative on this side, and as Deviant said, the way he gets this off, and it worked perfect for me, is just to, oops, flick it out. So hopefully I didn't disrupt that too much. So there's that. So now you just take the two clamshells together. You have your piece. The clamshell that I printed came with a base, which is awesome. Goes in like that. And now this is set to be poured in. I just kind of bend this back a little bit to create a nice gap to pour the metal down into. And now I come in and I get a ingot out. Put that into the ladle. and light the fires. And this actually takes little to no time to melt. It's already starting to melt right now. Okay, it's completely melted. I'm just heating it up to make sure it doesn't immediately solidify. Okay. And then just pour down in. That's it. Now we wait. I believe wood's metal probably cools faster. It's got a lower melting temperature. This will stay maybe 1 to 2 minutes max to fully harden. But while we're waiting for that, one thing to talk about and remember is, although this took me some time, all in all, from the time, if I could have easily had this clamshell with the clay put in, some release agent already put on it and in my pocket. And I could have gotten a hold of your key, placed it in real quick, squeezed it together and stepped on it, all within less than a minute, put that clamshell back in my pocket, return someone their key, and take it back to another location to do this part of it. So really, you only need access to the key for 30 to 60 seconds to be able to duplicate someone's key unawarely to them. So I need a key to go unlock this door. Great, here it is, bring it back as soon as you're done. Cool. You walk off, unlock the door, make a copy of it, and you would have that copy. So still a little liquid. So we'll wait. This silicone pad's quite nice, by the way, to rest this on. Thanks, man. I guess I could have used my tray.
What's your infill on that clamp?
What do you mean? Oh, 50%, I think. What's that?
That's because you stepped on it. So
Yeah, it's 50%, I think. Yeah. Yeah, it's still liquidy. I can see it. Just bouncing the table. It's almost there. One thing I want to test that might work, I'm not positive on this, is to hit it with some upside down compressed air out of an air can. It might solidify it faster. So yeah, I have no clue. I remember thinking that this took way longer than I thought it would to finish. Because if you watch Deviant's video, he's already got his out. He's done. And I'm guessing that's just because it's the wood's metal, which has that 120 melting point. And I overheat mine a little bit because I want to make sure when I pour it out, it doesn't start like, if you've ever poured lead before, you know it just immediately starts hardening as you pull it out on top. We're getting there. A few little spots left.
what's your settings, Cura settings for your keys? Normal, fine, extra fine?
For the clamshell or the keys?
The keys.
I've done them in all. Normal works fine. The 1.5, I think, is what the normal is on Cura. Worked perfect. It's 100% infill. And then the supports for everywhere touching the plate. Okay, I think we're somewhat solidified. Let me just tap the top here to make sure I'm not completely, still some soft spots. But for the most part, I think we're good. We'll wait a couple more seconds here just to verify. Take it out of the base. Okay, I think we're probably good. Let me see how hot this is. A little warm still. Not like burn your hands warm, but don't need to take it out anyways. You don't need to rush this part. But if I took it out anyways, it'd be too hot for me to hold to put into the keyway to show you. So we'll just give it a second. In Deviant's video, he also talked about making a port for the air to come through. I didn't do it on this one. Technically, this clamshell on the side has one, but I didn't drag it off into it. I didn't use it last time, and it worked fine. So, okay, we'll open her up and see what it looks like. Hopefully, I'm not about to pour hot metal over myself. There we go. So there's the mold of the key. Let's see if we can knock this out of there. How hot is it? No, we're good. So there's the key. And you can see how even I got it far enough down that the head of the key was inside the mold. And now I have the extra spillover is enough to hold on to. And this is this is exactly 1 ingot of that metal from that ice cube tray, which means you know exactly, you don't have to worry about how much you melt. You throw 1 little cube and you're good to go. So now the question is, does it work? And hopefully it does. Yep. So that is the molding process. So I should test this now. Yeah, see, this clay to me is still soft. It is kind of a pain in the butt to clean out of the 3D printed model. I might next time think about putting some talcum powder on the model before I put the clay in, but it's not that big of a deal to get out. So I will clean that up later. Okay, so credits. Keygen.co. So there was originally a talk at DEF CON 21 by David Lawrence, Eric Van Albert, and Robert Johnson. The YouTube video's up there called Key Decoding and Duplication Attacks for the Schlage Primus High Security Lock. They talked about 3D modeling these and how they could do this. And then they created Keygen.co. And it's underneath Eric Van Albert's GitHub. And it's actually a command line script you can run. They've converted it into a web page, but you can literally just input data through a command line and it spits out the STL file for you. And then Deviant Ollam, obviously he gave the inspiration for the video, the entire tutorial. So his website is deviating.net, his Twitter account is Deviant Ollam, and then the original key molding video and casting video is also linked up there on the screen. And that is it. Any questions? Yeah.
I forgot it. Well, you said it. I mean, so you could go in pretty much locked and loaded, ready to copy a key.
Right. So you could already have this clay pre-created, put a lot of talcum powder on to make sure when it's in your pocket and heats up, it doesn't start gooing together, and just have this down in your pocket, or in a baggie in your pocket if you're worried about the clay. Say, hey, I need to get a key to get into the server room or the XYZ room. You get a hold of that. And for example, if you're, I mean, not that I'm condoning this, but if you're an employee, it'd be pretty easy to get a key to a room that you weren't supposed to always have. And at this point, you would always have that key. And in theory, once you have a duplicate of the key with molding, you go back to the 3D modeling. Don't have to 3D model it, but at that point, use a calipers or a key decoder to get your depths. Go to a locksmith and say, hey, I have a Schlage, keyway or a Kwikset KW1. I need to cut to this code. You give them the code, and boom, you have an actual real key you can use whenever you want. So.
How does the putty actually dry?
I'm sure it does over time, but so I keep it in the wrapper, and then to add additional, I went a bit overboard. To additional storage, I 3D printed a case for it, so creates a nice little seal around it, and when I put it with the rest of the stuff, it doesn't get smashed. So.
What's your print time for the keys, like in a normal setting?
Yeah, so the normal setting, so another note on that. When I 3D print the keys, I actually set the print speed to 50%. And the reason I do that is because the warding is so small, when it goes, it just rips up it won't adhere. So I slow it down to 50%. So technically, the full-size Kwikset key, I think, takes like 18 to 20 minutes. And I printed this master lock key in 9 minutes. So they're fast. I mean, there's not a whole lot of material here. So.
What kind of durability is the 3D printed ones?
Not good. Yeah. It's a single-use kind of scenario. But it would be one of those things where, like, if you were having to get into somewhere, this is something I didn't also touch on. So I showed this key working in this deadbolt. But there's no actual throw to this deadbolt. There's nothing, it's not moving the bolt. It's just a freely spinning lock. This one has a little spring tension on it, so it technically is working under spring tension, but it's not much. So a couple people do things. If you look at like the key compared to my 3D print, you can see it's not quite as tall, and that's for a reason. It didn't fit, so I over-sliced this off. But the other thing you could do is you could chop the entire bottom half of this key off. And in the lockpicking world, if you know what this is, which I know Steve does, put a tension wrench in and actually use that to create the turn. And really at this point, this is just lifting the pins to the proper height. Don't have a tension wrench, small screwdriver. Deviant even says the same thing. This field's metal. I mean, it's decently strong, but I could take this right now and just bend it if I really wanted to. Twisting it, it moves back and forth. It's pretty soft. But if you wanted to, you could use a tension wrench to actually jam into the doorway with it to apply the pressure, or a screwdriver. So.
Can you use them as patterns for blanks at Menards?
The 3D printed one, I believe you could. Actually, I should try that. I haven't tried that, but I believe on 3D printed it would be durable enough. This one might be too. Because if you're talking like the minute key scenario, that would possibly work. I mean, technically, if you walked into a locksmith with a 3D printed key, or this molded key, or your local tool store, hardware store, and ask them to duplicate it, they would be able to. You would probably get some interesting looks. But again, the point is that once I have the duplication of this key in this format, at that point I take it over here and I get my depths. And it's not as weird to call up a locksmith and say, hey, I got a quickset key and I need the code cut. It's 42315.
You think that's less weird?
Yeah, it's like I need a duplicate of my key, because code cutting, so duplication, a duplicate of a duplicate of a duplicate, obviously the quality.
Normal keys don't have that number written on it. You would have to have.
No, some do, some don't. But for example, on this master lock, it's got the key code 3297. That is not the bidding, right? But if you have a program called InstaKey, which is $9 a month or $10 a month, you can literally go in and say, you type in 3297 and say it's a master lock. It'll pop open and it's like 4 or 5 pin. You're like 4. It'll tell you the bidding code for this key and this lock. If you have a master lock combination lock, on the back there's a decent string of numbers. Go in, say combination, boom, it'll tell you what the 3-digit combination is for that lock.
Is that made by Master Lock?
No. It's called, I don't remember the name of the company, but it's InstaKey.
So it's obviously there's a way to calculate it or something.
Right. Or it's information that is, I mean, technically you're supposed to be a locksmith, I believe, to get in the profession to get access to it. But according to what I understand, it's probably not that hard. They'll take your money. So, and it's a mobile app, so you can do it on the go.
Do they have like handheld key cutters that like where you could dial?
Yeah, they have really crappy ones,
Yeah.
but the one we're gonna get is the HPC Blitz. So it's not electronic. It's actually very cool. Everything's done with a card. So you want to cut a master lock number 3 lock. You pull out a card and it says master lock number 3. You slide the card in. You line the key up with this bar that gets it right up to the edge of the key, the bow of the key, and you lock it down. And there's 2 turn dials. And the first turn dial is I want to cut position number 1. And on the card you'll see a needle gauge go across. You turn it until it stops on 1. And you're like, I need the depth. And you turn this until another needle goes to like depth cut 3. And you literally press down on the handle and just chomps out that bit. The whole box is like this big. And you just get like an index of these cards. You slide the card in, and all the card tells you is where to move these 2 needles to get your position and then your depth cut. So it's a code cutting machine that's just punch, 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 punch. And I think they're like $100 or $1,000 to $2,000 new, but you can find them used on eBay, cheaper than that. What's that?
So I'm gonna need the Huffy price on that.
eBay. So.
Well, thank you, Tony.
Yep, thank you.